And welcome back, students. Today we're going to discuss converting binary to hexadecimal. So recall that in our previous notes we talked about how hex is like a grouping of 4 binary bits. So to convert between the bases, we're simply going to look at the binary in groupings of 4 to write the hexadecimal number. So this is extremely easy conversion, a lot easier than when we had to do like the binary to decimal. So I'm just going to quickly give us our chart again that we had from our previous notes of the binary hexadecimal of binary numbers. So if you already have this in your notes, that's great. If not, I'm going to throw it up here again just so you kind of have a quick reference as we work through these notes. And here you can see, of course, binary going from 0000 all the way up to 1111, all right, which of course is hexadecimal values of 0 all the way up to F. Now, so let's start with a single grouping. So just one group of 4 bits. And for this example, I'm going to use 1001. Now, if we look back at our chart to see what this hexadecimal represents, so I'm just going to look back real quick. And according to that, you can see on here 1001 is represented with 9. So the answer, of course, is a simple 9. Now, let's look at a full byte. So now I'm doing 11000010. Okay, so I have 2 groupings in here. So let's start with the first grouping of 1100. If you look at the chart, you can easily see which hex number this is. It's just a C. If I look at the second grouping, 0010, I can see that the hex number there is 2. Lastly, I'm just going to take those 2 answers I've gotten out and combine it back into a single number, which in this case is C2. And that's really all it is for combining or for converting between hex and or from binary to hex. Now, if we say, let's say we have a non-8-bit. So remember we did basic binary operations such as addition, multiplication, and we occasionally had 9-bit numbers. We can convert those too. So this example, I'm going to be 100110011. So obviously we can convert the second and third grouping easily into 3. But what about that singular 1 that's just floating up front? Well, all we do is we add zeros until we have a grouping of 4. In this case, 0001. Which, of course, is just the hex number 1. Right, and of course, if you had a 3-bit 3 groupings, you would just keep adding a hex number for each grouping of 4. Right. So our final hex number in this example is 133. Now, when we're looking at these numbers, we already talked about going from binary to hex. Of course, we should talk about going from hex to binary. It's equally as easy, all right, because we have that chart to look at. So remember how we group binary into groups of 4s to find hex? We can do just the same thing in reverse to go from hex to binary. So let's look at an example real quick here. We're going to convert F5. So we're going to start with the F. What's the 4-digit grouping? If we look back at our chart, we can see that F is represented with 1111. Next, we convert the 5. Again, we ask ourselves what's the 4-digit grouping. If we look at our chart, it's 0101. And then we rewrite that into a single binary number. So our binary number, in this case, is 11110101. And that concludes your notes, folks. Until next time.